crystal and titanium. This is Apple Watch Ultra 3. Today you're going to get a little bit of a material science lesson that nobody asked for as we talk about the new Apple Watch Ultra 3. Sapphire crystal and grade 5 titanium. These are the materials this watch is made out of. My previous Apple Watch, I guess I'll call this the base model Series 10, the materials look pretty much the same, but in reality, they're completely different elements. This watch is made of glass and aluminum. The face of this watch looks like glass, but it isn't. It's sapphire crystal. If you were to sand and polish this rock down, it would be transparent. Well, this one would be blue tinted because of the trace elements of iron and some other stuff. Apple actually makes their crystals in a lab where they're optically clear, but it's the same stuff. These are actually the same compound if you were to look at them under a microscope. And the reason they use these materials actually comes down almost exclusively to hardness, with a bit of a marketing thing because people do associate titanium with strength. Personally, I think aluminum is better for electronics, but I'll get into that in a minute. First, I want to explain what hardness really is as a physical trait of a material. A surface, any surface, and whether or not that surface can get scratched can be simplified down almost entirely to hardness. If one thing is harder than another thing, the softer thing will get scratched when they come into contact with each other. For instance, here I have a titanium rod. Titanium is much harder than aluminum. Therefore, when I push the edge of this titanium rod onto this aluminum rod, it'll make a scratch on the aluminum. It'll leave a mark. If I flip them around, scraping the sharp edge of this aluminum rod onto this titanium rod, it will not make a mark. It actually can't. And the harder I press, check this out, if I push the aluminum rod hard enough into the titanium rod, it'll just deform the sharp edge of the aluminum. Titanium is a lot harder than aluminum, so aluminum can't scratch it or deform it. This is sort of the whole science behind the quenching process. If you've ever watched something like Forged in Fire where they're making knives, when you heat up carbon steel and then cool it really quickly, the edge of that steel becomes super hard. So then it can cut stuff without deforming its edge and it'll stay sharper for longer. Sapphire crystal is harder than most substances you'll come across in your daily life. The only thing really harder than this is diamonds. It's a lot harder than your desk, it's harder than metal, and it's even harder than the components of like concrete or the asphalt in your driveway. That's not always true for glass. So let's say you're fixing stuff on your car and you're working next to a bunch of steel parts. Steel can scratch into glass. Here's a steel rod and a slab of glass. To be fair, this is not Ion X glass like Apple uses in its non-ultra watches, which is apparently somewhat tougher than regular glass, but it's not harder. But with this steel rod, I can pretty easily gouge this little glass plate. Let me get a better shot of that. I don't even really have to push that hard, just pressing into it is enough. But on the crystal surface of the Ultra Watch, it just slides right across. And that's because crystal is harder than steel. So if you're a mechanic and you're deciding between this Apple Watch Series 10, or probably the 11 because that's out now, versus this Apple Watch Ultra, you can make a pretty good justification for the Ultra just because you're gonna be banging it against metal as part of your daily life. And some bolts under the hood are even gonna be heat-treated carbon steel, which is harder than regular steel, which will be hard enough to scratch the Series 10 and 11 watches. But not the Apple Watch Ultra. Crystal is certainly not tougher than steel. Toughness is a measure of how far a thing can flex before it fractures, or in your watch face's case, before it shatters. So crystal can still shatter like glass if you bang it on something hard enough directly. Although, man, the way this thing is put together, Tech Racks made a video a couple years ago with the first Apple Watch Ultra of just blasting it repeatedly with the hammer on a table, and he managed to destroy the table under the watch before the watch shattered, but it did ultimately shatter. So that's crystal versus glass. Now on to the body of the watch. The Apple Watch Ultra has a titanium body. The Series 10 or 11 have an aluminum body. Not only is titanium a whole lot harder than aluminum, it's also just about twice as heavy. This is about how much metal is in the Apple Watch Ultra. This is 35 grams, and this thing is made up of about 30 grams of titanium. Obviously, the smaller Series 10, I don't know how much it is, but it's a lot less aluminum than this rod. Titanium is close to twice as heavy as aluminum. However, titanium is also much stronger than aluminum by weight, which means you can use less material to achieve the same strength of the frame. If you're talking about the same watch, same frame, the walls can be thinner if you're using titanium. So although it's a heavier metal, you get to use less metal to make it, which in this case allows the Apple Watch Ultra to have even more battery than it could if you used an aluminum body for it. And since it's also a harder metal, it's much less likely to scratch. Our same mechanic example would scratch the crap out of his aluminum bodied watch, since aluminum is softer than basically everything under the hood of a car except for rubber hoses and plastic. The titanium one is a similar hardness to hardened steel, so mild steel won't scratch it, but a hardened steel bolt can. This is not an example of the bolt you find under the hood of your car. Back to the weight thing, man, this is a lot heavier than my Series 10 watch. It's noticeably heavier. 36 grams, 62 grams. You do notice it right away the first time you wear it, but actually after having this on for a few days, I don't notice it anymore at all. The Apple Watch Ultra has way more battery than the Series 10 and 11. And battery density translates pretty much in a straight line to battery weight. Something has more battery, it weighs more. And we're still in my first week of owning this watch, but the battery lasts for like 2 whole days. That is cool. From the top down, the size of this doesn't look much different at all from the Series 10 and 11. I always thought of these as like massive Apple Watches, but from the top down, the screen face really isn't that much bigger. It's the thickness that gives it that really extra chunky look. And actually looking at that, I see now why it's a whole lot more durable. The edge of the glass on the Series 10 and 11 is rounded, so it just kind of wraps around the case of the watch. So when you're wearing your watch, if it's banging on something, it's gonna be the glass that's banging on that thing. But with the Ultra, the titanium case comes up and sort of wraps around the edge. And then the crystal face is perfectly flat. So whenever you bang this on stuff, most of the time it's gonna be banging against the titanium, not the face of the watch. I know they use titanium partly because this is like a luxury metal. And it is. Titanium can be as much as 10 times more expensive than aluminum. But there's such a little amount of metal needed for a watch case that that's really not the reason for the price. This is more than enough titanium to make a watch case, and I got this for a little more than $6. Another thing is that because of the properties of this metal, it takes more specialized drill bits to mill it. So part of the cost of this watch is that it's harder to make, but really titanium is just a fancy metal for a fancy watch. Where aluminum wins out over titanium, and the reason that I'm happy they're switching to aluminum for the body of the iPhone 17 Pro, is heat transfer, thermal conductivity. This probably isn't really a concern for Apple Watch. I don't think anything I've ever used my watch for, other than maybe when it's charging, has caused it to heat up. It's not like we worry about thermal throttling the CPU inside your watch. But still, because I find it so interesting, I've devised a way to illustrate just how much better an aluminum case is at moving heat off of the CPU than a titanium case is. This is an aluminum rod. This is the same sized titanium rod. I have them wrapped in gaff tape because that's the only way my thermal camera can see the heat moving through them. When they're shiny, the infrared doesn't get picked up. I'll put these side by side, and I don't think I even have to speed up the footage. Okay, I've got this thermal camera looking at these two rods. And you'll see when I heat up both of the rods, I'm just gonna blow fire across the top of them. As I heat up both of these rods, the heat is gonna travel down the aluminum rod pretty quickly, where in the titanium rod, it's just gonna stay at the top where I'm heating it. This is not sped up. I'm showing this in real time. So that's all it took, and I'll even stay on the titanium rod. Let me just blow fire just on that. I think you can see that I'm doing that. Yeah, you can. And look at that. The bottom of the titanium rod is cold. I can just handle it. The bottom of the aluminum rod, I don't really want to touch because it's super hot. Okay, it's not super hot, but it's hot. You can see the heat has traveled the length of the aluminum rod. It has just stayed right at the top of the titanium rod. Still even. It takes 10 times longer for heat to travel down titanium than it does for heat to travel down aluminum. That's why so many components are made out of aluminum. The heat saps away from the heat source and goes towards wherever it's cooler. And similarly, it will more easily escape into the air. Again, for a watch, this is basically pointless. The scratch resistance of titanium is way more important than the heat shedding properties of aluminum. But for a phone, if you play a lot of games, or even just for having it in your car while it's charging, it gets super hot. Phones can heat up to where they'll shut themselves off if they're in the sun, or just slow themselves way down if you're playing games. And having a titanium frame on your phone is making it so it's almost like a little jacket, like containing the heat. I know the actual frame of the phone is made out of aluminum, so it is spreading the heat out. But glass is not very good at transferring heat. Titanium's not very good at transferring heat. So having an aluminum frame is gonna make a difference. And it's not just a little bit better at moving heat, it is 10 times better at moving heat. Anyway, I'll talk about that more in the iPhone video. My iPhone 17 should be here today. For a watch, I don't think heat is a concern at all, and titanium won't scratch as easily as aluminum will. So if you live a life of banging your wrist against things for one reason or another, you've got yourself an excuse to spend this extra money. Well, also the battery life. If you want to take advantage of the new sleep score feature, you'll need the battery to last the night. So having such a bigger battery buffer gives you more time throughout the day to find an hour or two somewhere to charge it. Or if you're like an Ironman triathlete, not to brag, but I am a 2-time Ironman myself, the Series 10 cannot track activities for an entire day. It'll die. There are, of course, lots of other features and things to talk about with this watch, but I wanted to keep this video specifically to the crystalline titanium that it's made out of. And I think that I've managed to do that now. So, goodbye. Cut the feed. I'm not getting up. Hmm.